Hey Stellar Sixes, it's time for math. So last time we talked a lot about working with big numbers and expressing big numbers and thinking about big numbers in different ways and writing big numbers in a couple of different ways. And today we're going to get down to working with those numbers and doing some of the mathematical operations that we know how to do with really big numbers. So let's review, first of all, what operations are. In math, we have four main operations that we use to solve problems. We have addition, subtraction, multiplication, and division. So those are the four main operations that we'll be using when we're solving math problems. Now, in addition to that, when we get a tricky word problem, we have to think sometimes really hard and look for clues to know which mathematical operation we need to use to actually solve the problem. So when we just get an equation that says like 741 divided by 8 or something, well, we know what to do. We know how to solve that problem. We can pull out our skills and our toolkit and do long division and solve it. But when we get a word problem or a question that is written out in sentence form, it can be sometimes harder to figure out exactly which operation we have to do. So we have to use some sleuthing skills. We have to understand math vocabulary and know what different clues are for different operations. So we're going to take a look in our textbooks on page 52, and you don't need to have it out because I'm going to show you when it's necessary for you to see. I'll put it on the screen in the lesson for you to see the details of the problem. So our problem is about figuring out how many cell phones there were in Canada in 2007. Let's move on. Okay, so our problem says the population of Canada was about 32,980,000 in July 2007. Data show that there were about 497 cell phones per 1,000 people that year. How many cell phones were there in Canada in 2007? So we have to use some of our math vocabulary skills and some of our detective sleuthing skills to even know what this problem is asking us to do. So one of the things that I recommend for solving problems is to highlight the most important information. And you don't have to actually use a highlighter, but just in some way draw attention to the things that you need to know for your problem. Now, it's math, so numbers are probably going to be a really big part of what we need to know. So I have a number here, 32,980,000. I'm going to circle that number so that I can come back to it because I believe it's going to be important. We have the year 2007, so we could identify that might be something important for us, and we'll go back and evaluate whether it is. Data show there were about 497 cell phones. That may be important, so I'm going to circle it as well. And per 1,000 people, that's another number, and then we've got the year again. So I think we need to know what the year is. If I read the question again, especially this last part right here where it says how many, that's a good clue to me that this is part of the most important part of the question, because how many is definitely asking me about an answer to a math problem. It says how many cell phones were there in Canada in 2007. So I think the year is only important so that we can match 2007 to this 2007. But I've got it underlined just in case it comes up. So far I know that I have some important numbers and I have circled them so that I can come back to them if I need to. I also want to now figure out where are some of the clue words. So the clue words in a math word problem are going to be the words that are math vocabulary. So I already mentioned how many. I'm going to underline that because how many is asking you to answer a math problem. So I know that's very important where it says how many. Another word that's a clue for me is per. So per is a word that gives us a clue that we are dealing with a multiplication or division problem. Okay, so we will learn a bunch of good math vocabulary words this year that are good clues for solving math word problems. So per is one of the ones that we can put in there right at the very beginning. It's a clue that we need to solve a problem using multiplication or division. Okay, so that is a very important sentence. Data show that there were about 497 cell phones per 1,000 people that year. And by that year, they mean 2007, which we know that we are just cross-referencing 2007, that year, which is meaning 2007, and again, 2007 here. So we know that we're talking about the same year in all three sentences. Now, let's go back to this important part. 497 cell phones per 1,000 people. So that means that for every 1,000 people in Canada, there were 497 cell phones. So since most people don't own more than one, we could maybe say, and we don't know this for sure, but it doesn't really matter at this point, we could maybe say for every 1,000 people in Canada, 497 of them owned a cell phone. Okay? So those are two important pieces of information. But we don't have enough information with just that to say how many cell phones there were altogether in Canada in 2007, because there's a lot more than 1,000 people in Canada, right? Up here we know there's 32,980,000 people in Canada. So I think this word problem is going to require 2 steps to solve it. Okay? Because I've been told how many cell phones there are for every 1,000 people, but I have way more than 1,000 people that I have to know in order to figure out the answer to how many cell phones were there altogether in Canada in 2007. So let's look at how we can solve this problem. Well, the first thing we have to figure out, our first step in our 2-step problem, is to find out how many groups of 1,000 groups. How many groups of 1,000 people were there in Canada in 2007? And once we know that, we will be able to take that answer, the answer to this problem, and multiply it by 497 to give us the answer of how many cell phones were there in Canada in 2007. So our first step is how many groups of 1,000 people were there in Canada in 2007, and then the second step will be multiply by 497. Okay? So how do we figure out how many groups of 1,000 there were in 32,980,000? Well, when we're asking how many groups of something are in something, that is a division problem. So what I need to do is to figure out what is the answer to 32,980,000. Well, I should have left a space, so why don't I put a comma just to be on the safe side? Because I don't want to get mixed up with between my hundreds, thousands, and millions. And then I'm going to divide by 1,000. So you may look at that and go, Okay, cool. I don't know how to do that, right? Because last year you probably didn't learn much about how to use long division with a divisor that was bigger than one digit. But hopefully you remember from learning about multiplying and dividing large numbers last year that when you are dividing a number by 100 or 1000 or 10 or whatever, that you can just cross off zeros if they both have zeros at the end. So however many zeros there are at the end of a number, you can cross them off to keep track when you're dividing. So if I'm dividing by 1000, I can cross off 3 zeros from this to get my answer, as long as it ends with zeros. If this number ended with other digits, I would not be able to use that trick. But it does, so I can. So I'm going to say, well, I've got 1 0 here. There, I've crossed off. I have to make sure that I match. And then there. And then one more. So now I have a problem that is 32,980 divided by 1. Well, any number divided by 1 is that number. So my answer is 32,980. Okay, so that tells me how many groups of 1,000 people were in Canada in 2007. And the answer is 32,980. So now I know my next step, because I thought about it before when I was thinking about this word problem, to get the answer to this, how many cell phones were there in Canada in 2007, I have to multiply the number of cell phones per 1,000 people, which is 497, by the number of groups of 1,000 people that there were in Canada in that year. So now my next step is going to be 32,980 times 497. Okay, now before you have a heart attack about multiplying that huge number, when it's really big like that, I'm going to say it's A-okay for you to use a calculator. Okay, so let's do this. 32,980 times 497. Okay, and the answer we get on here, you see on my little calculator, there's a little tick at the top to show where the comma would be, if we were using commas. Okay, so my answer is 16,391,060. All right. We're going to go through the steps that we followed one more time just to review and make sure everybody understands. How we came up with the answer to that problem. So looking in the textbook, here's our problem. The population of Canada was about 32,980,000 in July 2007. Data show there were about 497 cellular phones per 1,000 people in that year. How many cellular phones were there in Canada in 2007? So as you can see here, it's coaching us through this two-step problem. The first thing we need to do is figure out how many groups of 1,000 there are in 32,980,000. To find out how many equal groups, divide 32,980,000 by 1,000, and that gives us 32,980. That's a really important number for us to keep track of. Okay, it's our first step in our problem. We need that number in order to answer the next problem. So then we also know, because we were told up here, that there are about 497 cell phones for every group of 1,000 people. So we can take that number, 497, and we can multiply it by this number that we got in step 1. And the answer that we get when we do that big multiplication problem using a calculator is 16,391,060. 391,060. So one way that you can check, if you're just not sure, sometimes you think you've solved the problem in the right way, but you're just not sure, you can use estimation to check if you're in the right ballpark. So in this case, they're recommending we use the strategy of benchmarks. So if you remember from working with our big numbers last year in grade 5, benchmarks is a strategy where you try and find a number that's easier to work with, that's close to the number that you're given. So in this case, we have the number 32,980,000. Okay, now it is closer to 30,000 than it is, or 30 million than 40 million, right? Because our 2 is way closer to 30 than it is to 40. Okay, so our number here is closer to 30 million than 40 million. Now, 30 million is a nice round number that we can work with. If we divide 30 million by 1,000, again, we're going to cross off those zeros, okay? And that will give us 30,000. So we can be doing all this in our heads, right? This is if we don't have a calculator, we don't have something to write down on, and also just when we're checking, or if we're asked to estimate and we don't have to find the exact answer. So far we can do this all in our head. 32,980,000 is closer to 30 million than 40 million. 30 million divided by 1,000, in my head, I'm just crossing off 3 zeros, and I am left with 30,000. Now, 497 is pretty close to 500. It's only 3 away. So we'll use the number 500 to work with. 30,000 times 500. You might think, I can't do that in my head, Ms. Clark. Like, come on. But again, remembering back to last year and thinking about multiplying and dividing by tens, hundreds, thousands, well, our trick for dividing was cross off the zeros. Our trick for multiplication is add them on. So what we do with this is we take our 3 and our 5, and we're going to multiply them together to get 15, right? Then we count up how many zeros we have all together. So with our 30,000, we got 4, and with our 500, we've got 2. So 4 zeros and 2 zeros, that makes 6 zeros all together. And we put them in here. And if we add those 6 zeros on, our total number is 15 million. Now, 15 million is pretty close to 16,391,060. 16,391,060. So it's pretty close to the answer that we got. So we can say it's a reasonable answer after we did our estimating to check to see if it was reasonable. I hope that helps you guys. Again, if you have questions, bring them to our meet. Try and get a head start on the problems so that you don't get stuck at the end of the week trying to catch up and get everything done and you have problems. It's been great doing math with you, and I'll see you soon.